Hello. On this video, we're gonna go over how to sketch the graph of a piecewise function. And we're gonna need to recall what the parent function of certain functions are. And we're also gonna have to remember what a constant function and a linear function. And also, it's very useful to know how to get the slope of a line, the y-intercept. So let's start with the quadratic, which is right here. So we're gonna start with the quadratic. And if you remember, we have the quadratic function is the parent function. So let's try to recall how the parent function f of x equals x squared looks like. So if you remember, the vertex of that function is at 0, 0. Then we have another coordinate at 1, 1, minus 1, 1. The next one is at 2, 4. So it's gonna be around here, and minus 2, 4, somewhere around there. So the parabola looks something like this. Now we have to consider that on that function x squared, we have a minus 10. So that means that the graph is shifting 10 units down because the 10 is a constant. It's not inside of the exponent. So we have to shift the graph 10 units down. Instead of starting at 0, 0, we're going to start at 0, minus 10 down there. And if you notice, the first point is 1 unit to the right and 1 unit up. So we're going to have it here and here. So basically, we need to have an idea of what the graph is going to be looking like and where it is going to be located. So now that we know that we are going to sketch a parabola, we're going to select this option. And first, we need to locate the vertex. So the vertex is here. And then the direction of the parabola, whether we have a parabola going downwards or upwards. So this one goes upwards. In order to have a parabola going downwards, we would need to have a negative coefficient on the x squared. So this one is going to go up. And then we need to select another point, because if the coefficient is not 1, we need to take that into consideration. So if we had a coefficient of 2, the first point would be 2 units away or higher than the vertex. If the coefficient next to the x squared were 3, we would have to consider a 0.3 units up. So, but right here is the point that we need. Right now we have the graph of the function, but without considering the restriction. And the restriction is that we're only going to consider what's happening on this graph from -4, considering the -4, and all the way to 4, but without actually reaching the 4. So if you want to get a rough idea of what this graph is going to look like, you can sketch the limits of that interval. So one is going to be at 4, and the other one, we're going to have it at -4. So within those boundaries, the way the graph is going to behave is going to be based on the expression 10 minus 10 plus x squared. Everything going from -4 all the way to 4 is going to be based on -10 plus x squared. But considering that the -4 is going to be a closed or a dot and an open circle on the 4 because of the equal sign here. And we don't have an equal sign next to the +4, so that's going to be an open circle. So now we have to be very certain of the position of where those lines intersect our graph. If you want to be completely sure, you can do it visually and we can get an idea. But if you want to be perfectly sure, you are going to evaluate this function with a -4 And that means that here you're gonna substitute a -4. You're gonna end up with 10 plus -4 squared. So that means that you're gonna get -10 plus, and -4 squared is gonna be 16. That means that the answer is 6. And that works for both +4 and -4. That means that at +4, it intersects the graph at 6 and also at -4. But those are just our reference points to cut the graph. We are not yet sketching the whole thing. So I'm just gonna go and select the scissors to cut and write down those coordinates. The first one was -4, 6. And I'm gonna plot this point. And then once again, I'm gonna write 4, 6 to plot the other point. I'm gonna get rid of those sketches. And this is where the graph needs to be cut. But if you recall, we had those boundaries, but this one needed to consider, let me go back, an open circle and the other one a closed dot. So let's do the cutting. So we're gonna use the eraser and we're gonna erase everything outside of those boundaries. We just wanna consider that piece of the graph. Then we can use the solid dot and the hollow dot or open circle on the edges of our graph. So if you notice, we're only using the part of the graph that's inside of the boundaries going from -4 to 4 without touching the 4. Then we need to consider the constant function, 6. So that function is a horizontal line going from side to side at 6. So with that in mind, we need to either sketch the whole line. We could. One way of doing this would be just to select any 2 points and sketch the line. And then, because we're using only values that are less than -4, that means that we're only gonna consider everything that's less than -4. So from this line, which is the edge of the previous one, the previous graph, everything that's less than -4. So 6 is only gonna be used from that line to the left. We can figure out that the point where we need to cut this graph is at -4, 6. That's one way of doing this. So I'm gonna get rid of all of that, and I'm gonna cut the graph at -4, 6. Once again, this is one way of doing it, and then I'm gonna erase those segments of the graph. And I will stay only with that side of the graph. Another way, and because I have both a closed circle and the 6 would produce an open circle, at the end, because they're both at the same position, the solid dot is the one that will be remaining. Another way to save some time, if you already know that the graph is gonna be like that, you can just sketch it from the start. You can get rid of that, and you can just sketch a line going from this point and to the right. That's another way of doing this if you already know how the graph is gonna be. So that's a line that is a constant at the height of 6. just considering values that are less than -4. And this line ends with a hollow dot, but because the U-shaped function has a solid dot, the solid dot is the one that will be, in a way, winning over the hollow dot. And finally, we have a linear function. If you remember, a linear equation in the form y equals the slope m times x plus b. M is the slope and b is the y-intercept. So we can use that to have an idea of the way this graph is going to be looking like. So this is telling us that we're going to have a line that crosses the y-axis, this -2, at -2, that b is equal to -2. And the slope is 2, or 2/1. This is how much we're changing on y, and this is how much we're changing on x. So that means for every move, for every unit we move to the right on x, we're going to move 2 units down. So 1 unit to the right and 2 units up. 1 unit to the right, 2 units up, and we can keep going like that. 1 unit to the right, 2 units up, 1 unit to the right, 2 units up, 1 unit to the right, 2 units up, and so on. So we can find as many points as we want on this graph, but we have a restriction. That restriction is that we're only going to be using values that are greater than or equal to 4. So 4 is right here where the other graph ends. So we're going to have this. So the graph would look something like this, crossing the y-axis at -2 and then moving 1 unit to the right and 2 units up. Or you can also be moving 2 units, 1 unit to the left and 2 units down, because that is actually a slope of +2, minus divided by minus, so that would be 1 unit to the left, 2 units down for the next point, 1 unit to the left, 2 units down, and so on. But because we just want to sketch the graph 2x -2 on this side of the vertical line, so we're just going to keep that segment of the graph. So we can use this, the ray, and we're going to click on the first point, and then we know that the second point would be here based on the slope of the line. So if we, whoops, I was using the eraser from Aleks. Let me bring back the line to sketch the ray again. So I'm going to sketch the ray. I'm going to click on the edge. I'm going to click here. And now I'm going to get rid of everything that I have here. Now, once again, the parabola will have a 4, ends at 4 with hollow dot, an open circle. But because the line ends at 4, but with a solid dot, the solid dot will win. And we will end up with a graph that looks like this. So just to make sure that we got everything right, we had to sketch a parabola that shifted 10 units down. So we have a parabola that had to be at -10 and starting there. But we just needed the segment of the graph that was inside of these boundaries, going from 4 to -4. So that's why we just kept that segment, and we had to cut the end behavior of the graph. Then we had a constant function, 6, that was only going to appear on anything that was less than -4. Between -4 and 4, we were going to be using -10 plus x squared, and anything greater than or equal to 4 was going to be based on the function 2x minus 2. So each one will have its own piece of the graph. And the question whether this is continuous or not is based on whether you can walk over the graph without missing a beat. So you don't have any segments that are incomplete. Every part of the graph is connected to the previous one. A graph that wouldn't be considered continuous would look something like this, and then the parabola starting here, and let's say the other line starting here. So if you have a non-connected segment like this one, that would be a graph that won't be considered continuous. So hopefully this helps, and just let's check our answer. Yes, it is continuous. Right. Thank you very much.